Opener 13. If you looked at remember a prior example, we were looking at x plus h squared and how it related to b and c. And we found that b was the same as 2h and c was the same as h squared. And that's if you had the situation x plus h squared, or you could think of it as x plus h times x plus h. Now what happens if you don't have h in both places? What if you have an h in one place and a different number, a k, instead in the other place? How do h and k now relate to b and c? So that's really what we're going to spend this opener thinking about and talking about and discovering. And the best way is to look at a bunch of examples and see if we can draw some conclusions. So I'm going to look at distributing. So I get x squared plus 2x plus 6. Sorry, forget the 3x. Plus 3x plus 6, which is just x squared plus 5x plus 6. So let's just keep a running table here so we can keep track of what values we're getting and see if we can start to see any patterns. So this will be my h, my k, my b, and my c. So the first one, I got for h 2, k 3, b was 5, c was 6. Alright, let's keep going, see if we can figure it out. Distributing again. X squared plus 8x plus 5x plus 40. So that's x squared plus 13x plus 40. And keeping track. This was 5 and 8, and it gave me 13 and 40. Some of you might already see the pattern, but in case you don't, I'm going to do one or two more and see if we can come up with one. So here I'm trying -1 and -6. X squared minus 6x minus 1x plus 6, which is the same as x squared minus 7x plus 6 minus 7 plus 6. Patterns, patterns, patterns. One more. X squared minus 2x minus 4x plus 8, which is just x squared minus 6x plus 8, minus 4, minus 2, minus 6, positive 8. Well, hopefully you're starting to see the pattern. See what you can see between. How does 2 and 3 have to do with 5? And what does it have to do with 6? And then if you see something, does it have to, are those the same across the board? What does 5 and 8 have to do with 13? And what does it have to do with 40? Does the pattern continue? So hopefully by now what you've seen, or will see, is that when you add h to k, like 2 and 3 gives you 5, that will give you b. 2 and 3 is 5, 5 and 8, 13, -1, -6 is -7, -4, -2 is -6. So this is why you know those skills of being able to add integers starts to come into play. Because if you can see this pattern, then you can take advantage of it. So that's h and k as it relates to b. Well, what about c? 2 and 3 to 6. 2 times 3 is 6. 5 times 8 is 40. So it appears that h times k gives me c. -1 times -6 is positive 6. -4 times -2 is positive 8. 5 times 8 is 40. So let's make some guesses now and see if it's right. So x squared. And that x squared is always a 1x squared because I do have a 1x here. Now, Later we're going to start looking at, well, what happens when you don't have a 1x there? How do you deal with this? But for now, we know it's 1x squared plus b is just h plus k. So negative 8 plus 4, which is my b, times x, plus my c value, which is the product of the two. So negative 8 times 4. Rewriting that. X squared minus 4x minus 32. So let's check it. Distributing x squared plus 4x minus 8x minus 32, which is the same as that. So it works. Now, as you go through, you're probably not going to write it out this way. You're going to start to just do the math quickly in your head or on a calculator and start to develop a sense for these numbers. So let's get to x squared plus 8x, because 10 plus negative 2 is 8. Multiplying them is minus 20. Now this next one, x plus 0, you'll often just see written like this as a distribution problem, right? Because plus 0, you just could write it on. But let's take our rules and see if it works. X squared plus the sum of the two, 0 plus negative 12 is minus 12x, plus the product of the two, 0 times negative 12 is 0, plus 0. Or I could just leave it as that, which you'd find is the same as the answer to that. So this problem helps you take what you used to think, which was that 2h equals b. Well, that is true, but really what you were doing is you were doing h plus h equals b when you had x plus h squared. You're just adding the h's, and then you are h squaring to get c, which is just the same as h times h. So what happens here is when you have different values there, if you have an h and a k, you add them to get b, and you subtract and you multiply them to get c, and that's only true when you have 1x and 1x. Okay, only when you have this situation will this be true. But if you have this situation and you recognize it, you can quickly multiply two binomials to get a trinomial, which is an important skill, one that will save you a lot of time and a lot of brain power.